Well, I'm back, and I did not mess with my login credentials, so I didn't want to lose my ability to record these lectures. So today I rode the bus, and I wore this because I was coughing. I mean, the train, and it went fine. But when I was coming home, I wasn't wearing it, and so I was on the train. I started coughing, and it made the lady next to me nervous, so she put one on, not wanting to catch my cold. Anyway, today I'm gonna give an introduction to what is structural concrete, and so I'm gonna again share my iPad, and we'll run it from there. Okay. Okay, there we go. Shut this down, and we'll talk about structural concrete. So Um, normally, I call this course reinforced concrete, but in the course catalog, it says structural concrete. So why does it say that? And so if you read the book, I think it's in Dolan's book, I'm not sure. Structural concrete means one of three kinds of concrete. So there's one, plain concrete, that is no reinforcement. Then there's reinforced concrete, which is the subject of our class. And then in the fall, hopefully we'll be able to offer pre-stressed concrete. And together, these three things encompass structural concrete. So let me talk about each of these three things in turn. So plain concrete. This means concrete with no steel in it. When would you use concrete without steel? Oh, maybe at the bottom of a statue. So you would have a monument like this, and these things tend to be massive, and this would be plain concrete with no steel in it, or very, very minimal steel. Then there's reinforced concrete, which is the subject of this class. Okay, this is concrete plus steel. And so why would you combine concrete and steel? Well, you took 3210 and you found out that in that class that we have the compressive strength, F prime C, and then we had this split cylinder strength, the tension strength, which was FCT. So this is compressive and this is tension. And if you remember, one of the big things we found out about that is that FCT was an order of magnitude lower than F prime C. The tensile strength was about a tenth. Like in our class, it came out to be about a 12th actually of the concrete strength. The other thing we found out in PSI was FCT was about 6.7 square root F prime C. But the main thing was that the compressive strength was in the thousands and the tensile strength was in the hundreds. And so to give you an idea of what that means to be a tenth, let's say you take a test and you get 90 out of 100, so you get A. That would be the compressive strength. the tensile strength would be a tenth of that, 9 out of 100. That's much, much less than an F. That's a fail. It's almost 0. So in fact, in this course, we're going to say that FCT is almost 0. We're going to ignore it. So that means whenever there's tension in a concrete member, it won't work. To overcome that, we use steel. So steel is good in compression and tension. Concrete is in compression only. And so the whole strategy of reinforced concrete is wherever there's tension, you would put steel. So if you've got a beam like this, and you load it, and it bends, so it looks like this. You see the top is in compression, and the bottom is in tension. So when you make this beam, you would have to have steel in the bottom because that's where the tension is. That's reinforced concrete, and we'll talk more about this in a bit. So finally, there's pre-stressed concrete. Okay. Concrete is bad in tension. So what if you could make it or rig it so that there's never any tension in the beam? One way to do that, so let's say you have a beam like this, and you're about to load it, is if you push the bottom like this, that will cause compression in the bottom, okay? And then when you load it, the bottom, which would be in tension due to this load P, would maybe not be in tension because of this load N, okay? And so how do you do that in a pre-stressed concrete beam? What you can do, one way, is you thread a bar through here. You pull a bar, and then you lock it down with a nut. And so it's like a giant rubber band in the bottom of the beam. And so this beam, when you put that load in there, is now gonna want to arch up because you've put stress in the bottom. So it wants to do that because you've got this pre-stressing force here. Now when you load it, it's possible to have the bottom not be in tension because this load N will overcome this load W. So that's pre-stressed concrete. So these three things together make structural concrete. So to summarize, structural concrete is made up of plain concrete with no steel, reinforced concrete, concrete and steel, where you put the steel where there's tension, and pre-stressed concrete, where the steel stresses the concrete before you stress it with load. So it's pre-stressed. But this course is reinforced concrete design, even though the title says structural concrete. So I noticed that when I stop the share, my face appears back up, and so you get to see me all surprised. So I'm gonna see if I can turn this off. Oh, I can't figure it out. Okay, so there I am, and then now I can see the end meeting button. I'll talk about flexure in concrete next.